So today I'm gonna show you the machine learning model that I have built for credit risk prediction, and along with end-to-end the front end of the model, and the backend Flask application, which serves the application over the local network, so that anyone on the local network can access that web page and input the data in the model and get the predicted results. So I'll explain about the business case. So this case was given to me from my company. So we are from a financial services sector, and we advance loans to lower income group clients, and we have around more than 1 million clients as of now that we are serving to them. So we have a large amount of data regarding our clients, and also the historical records of their repayments, and also about their whether they have settled the loans or defaulted the loans. So just using that data, historical data, and training a model over it, what I did was a training model over it, and I've gained some insights from that, did some exploratory analysis, and I found out like there's a way to predict the loan defaults in future from the given data. So I've just built a model from that, so that you can see it's a gradient boost classification model. So I have pickled it. Pickling means just saving the model and dumping it to your hard disk so that it can be used later. So this is the Flask app, Flask micro framework, so which serves at the back end. So we have to run a server at localhost. So from Flask, as you can see, I've imported Flask render template and request, and I've imported the pickle and the pandas library and the Numpy library, and the model library which I use, which was Scikit Learn, and from Scikit Learn there's ensemble learning method, which is gradient boosting classification, which is also a kind of a ensembling of decision trees, but it performs quite better than a single decision tree, because decision trees are prone to overfitting over the data. So as you can see, the app name is Flask name, and I've just assigned the variable mul to open this already saved the model gbc flask pkl as rb, and assigned the pickle.load the mul variable to ml underscore model. So I'm just routing the app. So I've defined the home page as return the render template home.html. So this HTML web page that I have created, as you can see it over here. So it's a HTML type doc sheet, and you can see they have defined it devices and classes, and just written the credit risk prediction, and here you have to enter the loan client details. So this is kind of form. So as you can see, it's a human readable code, and in the last there is a submit button. So once you submit the button, so the app gets the information, and then it gets all the information from those form fields, and then it puts into the list, and in that list again converted into a numpy array with 1 row and 8 columns. As you can see over here, it's converted into np array, and then it's reshaped 1 comma minus 1, and this option is set because I'm also getting the probability likelihoods of being the normal or being default. So just to present it into percentage, so I'm using this formatter and model dot prediction. So I'll may predict from the given values and the probabilities of those values, and I'll round that. And so this is for a value error if somebody fills an alphabetical uh, data into that form, so it will return into an error like please check if the values are entered correctly, and otherwise it will render template predict.html with giving these three values. This is the prediction from the model, the normal probability, like what's the likelihood of the loan being normally settled, or what's the probability of risky likelihood of the loan being risky, or it's gonna be error or default in future. So this is nothing, just array slicing, because we always get a result into a numpy array. So did the slicing over that, and in that 0 0 and 0 1, as you can see it over here, and it's gonna be rendered into that predict HTML template, and the app is running on the local host, with the port is gonna be 5000. So as you can see, this is the home.html, and if you're going to open this one, so this is our form for credit risk prediction, where the individual has to fill the data of that individual client. Suppose that I'm just filling the target age, like the client age is 25, her housing index. These are the proprietary terms, and I cannot explain it right now here. And the people ages below 17, that means the number of kids, those are below 17 years of age. And loan cycle means how many times she has taken loan. And the CBR balance is actually nothing but it's the record from the credit bureau that how much of an outstanding loan is still there in her name in that account, and the loan amount which is being approved to her, and total monthly expense, that's the her household expense. So that we are going to just put submit. When once we click on submit, the data is fetched over here, and from that form field it becomes the list, and that all things that I've explained earlier. So that's how the workflow is done. And then comes the predict HTML. So here we present the credit risk results. So if you open the web page, you can see I've designed a header and the prediction column. So if the result is 0, then the client is normal, else if it is 1, then the client is risky. So we get the normal probability and the risky probability, all these three for loan underwriting decision. So like there must be some cases where model is not very precise or sure, like it's kind of a case like 51-49%, like 51% are the chances the loan getting repaid, and 49% the chances the loan is going to default. So in such cases we can use we can do some more investigation, due diligence, and before taking the decision of sanctioning the loan to the client. So no model is perfect in this world. So we have an accuracy around 95.61% as of now, which is pretty good in this case. And I'll show how the model works. So what I have to do is just this down. So as you can see, the model is working and it's being hosted on the local host. So we can access the model from localhost itself. We just put localhost 5000. So you can see we are getting the template. So let's just fill the form and fill the values, which I have tried this afternoon, and so that just making the process quick, and just put the submit button, and we are getting the prediction result, which is 0.00. So that means the client is not risky, and the loan is going to be repaid in future, and the likelihood of that is 99.34%, and there's only 0.66% chance that loan is going to default. So this is the model which I hope is going to be deployed at the backend of my company, and this is gonna work for like I think in next 6 months we are going to uh, retrain the model as the data gets refreshed, and there is a new you can say behavior, like loan client behavior emerged, and we need the model to be retrained so that it can give more accurate result, and it has to be monitored over a period of 6 months or 1 year. So this is how the model works. So thank you everyone for this session.